Okay, this video is the practice problems for 4.1. So let's get started. Okay, here they show you two alcohols, right? Because they all end in OH, right? Equimolar samples of CH3OH and CHOH, right, CH2H5OH, are placed in separate, previously evacuated rigid 2-liter vessels. Each vessel is attached to a pressure gauge, and temperatures are kept at 300 K. So temperatures are constant. So I'm just gonna write here. T is constant. It's attached to a pressure gauge. In both vessels, liquid is observed to remain present at the bottom of the container at all times. So that means that whatever liquid there was must have evaporated. Liquid observed present at all times. No, it didn't evaporate. The change in pressure in the vessel containing CH3OH is shown below. Which of the following best describes the change that takes place immediately after CH3OH is introduced? So what we see is that the pressure over time increases, right? And that the temperature stays the same. So when we put CH3OH, which is what they're asking us about, they're just asking us about this one, and it's poured into a rigid container, some of the liquid molecules immediately evaporate into gas, right? Because those temperatures would make it evaporate. That makes the pressure rise, right? If the temperature is constant, right, and the pressure is increasing, that must mean that the vapor pressure is getting so high, and so there's a physical change because it's still methanol, right? Because it's methyl group right here, and OH, which is the alcohol, so it's methanol. You're just changing the phase, and what's being broken is it's being broken into little intermolecular attractions, like hydrogen bonding between methanol molecules, and which is allowing it to evaporate into gas and increase the pressure, right? And we see that here. So because a chemical change isn't happening, it's just that it's changing states. So it's not a chemical change. It's not a chemical change. And covalent bonds aren't even in existence here. It's not covalent bonds that are happening. It's intermolecular attractions that are being overcome. I would say that the answer is D. Okay, next question. So here we have a reaction of water, and water turns no, not water. Hydrogen peroxide, H2O2, turns into water and oxygen. And so this is a physical change. No, this is a chemical change. So this is definitely not a physical change. That's like the color of something, or this is chemically actually turning into an entirely different thing. And so this is a chemical change because you're turning one thing into a completely other thing. Bonds are being rearranged. And so here, although there is entropy, although entropy does increase, that's not the reason for this chemical change. What's happening is these bonds are breaking and new bonds are forming to create altogether new molecules. And the only way that happens if bonds are able to be broken and made anew. So that's number 2. Okay. The next one. Okay. For this one, You were mixing hydrochloric acid, right, and NaOH, right, which is sodium and alcohol, and they tell us they're both dilute and colorless. And so this is that's a neutralization that's happening because it's exothermic, and what is happening is due to a temperature increase, which were at the same temperature. They were combined, and they represent the following results. Look at evidence of the chemical structure that took place. So if those things are true, the temperature had to rise for some of these bonds to break, and so I would say the temperature of the reaction mixture increases because they were dilute. That means they were diluted in water, and they're colorless. So they were colorless, and because they were dilute, I would say the temperature is making the mixture increase. Now it couldn't be A because the resulting solution wouldn't be colorless, because they can stay colorless even if nothing happens. That's not evidence that a chemical reaction took place, right? Because they could have just stayed the same and been colorless. That's not evidence that there was a chemical reaction. For C, the total volume is equal to the sum of, and that means that nothing happened, right? If the volume is the same, that there's no reaction, right? That means nothing was either added or taken away. And then D, the resulting solution conducts electricity. There's honestly no way for us to know. There's no way for us to know if there was any conducted electricity. So we don't even know if it can. This is a big question mark. We don't know. Right? Next question. A student was asked to formulate a hypothesis about what would happen if 100 milliliters of NaOH at 25 was combined with 100 milliliters of magnesium chloride at 25 degrees. So this is a really popular mixture. And what's happening is something called a precipitation reaction. This is called a precipitation reaction, right? Okay. And a precipitation reaction means that solid precipitate is going to form, and that's evidence that a chemical change that is happening, because usually, if a solid is forming and there were two liquids combined, that's evidence of a chemical change, right? And so volume being added, the volume of the resulting solution will equal to the sum of the volumes. That means there could have been a simple mixture. This could have just been a simple mixture if something was just added. That doesn't indicate a chemical change, right? So it can't be A. This is too simple. The things could just be added. You could add water to anything. That doesn't mean there's a chemical change. B, the mass of the resultant will be equal to the mass of the original. That's just the conservation of mass, right? Conservation of mass. That'll always be the case. The mass in the beginning and the mass at the end will always be the same, because you cannot create or destroy mass. C, the resulting. This is what gives you evidence that a chemical change occurred, because it is a and lastly, it being clear doesn't really mean anything. Next question. A student was studying physical and chemical changes. A student carried out some procedures in the lab and recorded observations. For one of the procedures, the student concluded that a physical change took place, but not a chemical change. Which of the following could have been results of the feature? A cube was changed into a... When the two liquids were combined in the beaker and the beaker became hot, this is an indication of a chemical reaction having taken place. When two liquids combine and there is some type of resulting mixture being cloudy, that's a change of state. That's similar to the precipitate up here. It is a change of state. And then this changing as well, the reaction changing. So the only thing that was a physical change, I would say just it changing its form from a cube to a flat metal sheet. It's exactly the same. It's just shape was changed. And so that was A.